Good day. My name is Mrs. Madumbu. I'm going to take you for core mathematics, and my topic is numbers in probability and sets. Now, this sounds like a very simple topic, but the fact that I brought in the sets and I brought in probability, you will get the reason why I say it is a simple but very important topic. So I have just shown the illustration of our types of numbers, the numbers that we use in our number system. Now if you look at them, you have basically two major types, the real numbers and the non-real numbers. Now, I will just explain a bit on the non-real numbers, that these are the numbers that we are not using because we call them complex or imaginary. Sometimes we are doing some calculations, we tend to see an error on our calculator or so some other signs that you cannot proceed because the number does not exist. These are numbers that we will use at advanced stages in the learning of mathematics. But we are actually looking at our real numbers, which are divided into the rational and the irrational numbers. So the difference between the two basically being that the rational are the numbers that can be expressed as fractions. They can be expressed as fractions, and if we try to change them to decimals, these are the numbers that will give us the exact or terminating decimals, or they will give us the recurring or repeating decimals. So all these numbers that we are using, they also include integers, that is the whole numbers, the negative, positive, natural, prime, odd, even, cube, triangle, fractions, percentages, and decimals. While the irrational numbers are like square roots of those numbers that are not perfect. We always you work with them, and when we try to change them to decimals or we try to find their values on the calculator like pi, we have those numbers that keep on, they will not terminate, so they are non-terminating. Now, I've just taken the most common types and I've just put some examples, and these are the numbers that I want people to try as much as they can to have them in their minds. Not even to make one mistake, because there is an implication. If you try and miss out one thing when you are working out or when you are doing some presentations in probability and sets, you might miss the whole question. So natural numbers being our counting numbers, obviously, or our positive numbers ranging from 1, 2, 3 up to infinity, and our prime numbers. And I want us to focus on the number 2, on our prime numbers. 2 is the only even number which is a prime number. And I also want you to take note that we do not have 1 in this list. So in most cases, we miss out questions on probability and sets because we tend to include 1 in the set of prime numbers, but 1 is not a prime number. We also tend to miss out or leave out 2 because we think it's an even number, but it is the only even number which is a prime number. So this list is very, very important. Then we also have our square numbers. We need to work out or to know our square numbers and try as much as we can. In primary school, we used to do our multiplication table. This time around, we assume that your multiplication table, you know. But the square numbers, you need to know them so that when it comes to answering questions on probability and sets, you can always list them in the proper sets. And all the same, you also need your square numbers when you are doing your indices, you need to know, because sometimes there's where they just place it and you need to identify it for a reason. You also need to identify or to know your cube numbers. Just maybe the first 5 or so, and the rest of them, you must always have a way of finding them, either by cubing numbers, starting from the cube of 1 all the way, because there's a way they want you to list them, as you will see in the illustrations and the questions that we're going to work out together. It's also important to know our triangle numbers as one of the common sequences that we generate by adding our natural numbers. Like 1 we add 2 we get 3, then to 3 we add 3 we get 6, and then to 6 we add 4 we get 10, and so on. So I've just given these as examples of the common types of numbers that we always have in these 2 topics that we're going to look at. Now, I'm going to look at a few questions. I'll take you through questions with you that we are not even going to do calculations. These are questions that we can answer orally, just to show and appreciate the use of numbers, or the reason why we need to know our types of numbers. So my first question is on the 5 cards, which are numbered 1, 2, 6, 7, and 8. So the question says, put 2 cards side by side. In other words, it's a question whereby we need to form numbers. And sometimes when we have questions like the way they are given, sometimes people tend to get confusion or what, but what is needed in this kind of a question is to go through the question, read the instructions. You just see that it's just something very, very simple. It is simple to do, yes, but you need to know your types of numbers. The first part says you need to form a 2-digit number that is a multiple of 7. So it means you are getting 2 cards, then you put a 2-digit number, which is a multiple of 7. So if you know your multiples of 7, you will see that we have 2 and 1. We can put 2 in the first box, then we put 1 in the second one, then we make the number 21. 21 is a multiple of 7. You can also form another one. You can take your 2, then you take your 8, you put your 8 in the second box, you get 28. 28 is a multiple of 7. Now you are just doing 1, or you're putting 1, so but you had a choice of 2, which is a very lenient question. The second question says, now we want to make a 2-digit number, which is a square number. So here we are. Those of us who will confuse square numbers and other numbers, if you do not know what a square number is, then it means you cannot answer this question. So you need to know your square numbers. Just like I said, you need actually to recall, especially I think the first 15, so that in this case it will be easy. If I look at it, there is my 1 and there is my 6. I can actually put 16 in my box, which is a square of 4. Then if I check again, I have my 8 here and I have a 1. I can actually put in the box 8 and 1 in the second one and make 81, which is a square of 9. The third question is on the cube number. Now you can see that it's not going to be a question where they want you to tell us what a square number is or a cube number. You have to know them. And they come in situations like this. So now you need a cube number, right? Which is a product of multiplying a number like by itself 3 times. So if I get back to I can only see a 2 and a 7. 27 is a cube of 3, so I can put a 2 in my first box and a 7 there, then I get my 27. Finally, you are also required to know what a prime number is. So, but in this case, you are not going to put a one-digit number. Remember the question says two-digit number. So if I check, I can see a 1, I can see a 7, I can put 17 here. 17 is a prime number. And I can also start with 7, then I put 1, I put 71. 71 happens to be another prime number. So that is a question on types of numbers. There we go. This one says, Joel spins a fair 5-sided spinner numbered 2, 3, 4, 5, and 6. The first part says, write down the probability that the spinner lands on. There are two things that you are required to know here. First of all, you need to know your probability concepts. First of all, you need to know that it's like you are choosing from a total of 5 numbers. So whatever we are going to do, probability is always expressed as a fraction. It's out of 5 because we are picking out of 5 digits, right? So first of all, again, we need to know an odd number, which sometimes you find out that people know what odd numbers are and even, but sometimes when it comes to the numbers, they always mix up the two. So once you mix up, you can see that you might miss just calculating the probability. Now this is just identifying our odd numbers. There is 2, there is 5, sorry, there is 3, and there is 5. So it means in this case, it's 2 out of 5 numbers. So our probability is 2 over 5. The second one says a prime number. There comes the situation where I said sometimes we miss it. We think 2 is not a prime number, but 2 is a prime number. We have 2, we have 3, and we have 5. So 3 out of 5 numbers there. That's the probability, 3 out of 5. The third one is just the probability of the number 7. Now, do we have any 7? No. There's no 7. So where it is impossible in probability, the probability is 0. Then finally, they can just bring numbers, not necessarily to know the types of numbers, but sometimes they put statistics, this frequency distribution, where the items involved are numbers. And sometimes you find out that because the items involved are numbers, some people, they get confused, especially on the first part. I just brought this question especially for the first part where we are supposed to do the mod. We can see that as we are spinning the spinner, it means the 2s, they came out 3 times, and the 3s, they came out twice, and the 4s 6 times, the 5s 4 times, 6 5 times. So if we want the mod, obviously we want the one with the greatest frequency. So our answer in this case is 4. So sometimes because of the confusion with numbers, some people might write the answer as 6. But 6 is only indicating that 4 has the greatest frequency. So our answer is 4. And then we can also calculate our mean. And this is where, because we understand that by writing 3 as a frequency of 2, we are actually saying that 3 2s. So if we want to find the mean, obviously we want to do the total. We multiply 2 by 3, then we add it to 3 by 2, we add it to 4 by 6, and then 5 by 4, and 6 by 5. And we get our subtotal. I'm sure it's 86. Then we divide by the 20 spins or 20 trials, which means it's 20 numbers, which is going to give us our mean. So I finally have this question here where it says Paul has a set of 8 cards, and each with a number written on it. And the numbers on the cards are 1, 1, 2, 3, 3, 3, 4, and 5. Then we are picking one card at random. Now, we are having numbers and we are picking, and of course we are told that there are 8. It means whatever we want to do in terms of probability is out of 8. It says write down the probability that the number on the card is 1. So we can see that there are 2 1s on the cards, so it becomes 2 out of 8. 2 over 8, you can still simplify it to 1/4. Secondly, we need to pick out an odd number. So many odd numbers there. 2 1s, then the 3 3s, and the 5. Actually, it's 6 numbers out of 8. So our probability is 6 out of 8, which is 3/4 if we are to simplify. Then the common one, prime number. There goes 1 and 2. And this is where I said, the moment you try and include 1 in the list of prime numbers, you miss this question. 1 is not a prime number. You try and exclude 2, you miss it again, because 2 is a prime number. So if you check, there's only 1 number there which is not a prime number. It's only 4. So it becomes 7 out of 8 is our probability for picking a prime number. And finally, they say a number that is less than 6. And we check all those numbers are less than 6. So it's possible that any number that you pick, it's a number which is less than 6. And this is where the probability is certainly possible. Everything that you do, everything that you pick. So this is where the probability is 1. It's 100%. As opposed to the previous where it was not possible and it's 0, because our probability are just numbers ranging from 0 where it is not possible and 1 where it is certainly possible, and the rest of them are fractions depending on how likely it is. Now the last question, it is a very simple one, but it involves larger numbers. So that's why I said you really need to go through those lists and try and remember the first 10, the first 5, and so on. So we are using integers from 60 to 75 only. And these are the questions that we want people to underline that range, 60 to 75. We want people to underline that. So if we are to underline that, and even the word only, you find out that you know that you are limited to 60 up to 75. Sometimes people tend to relax just seeing a multiple of 17. They even start to think of 17 itself because it's the easiest, or 34 because they can easily multiply by 2. But this one wants us to keep on doing trial and error until we land in the range, because we move up. 17 by 3 takes up to 51. Obviously, it's 17 times 4, which is 68. And 68 is right in the middle of that range. So that is our answer. So it is also a question where we need to know other related concepts with numbers. We need to know the factors. We need to know multiples. So the language of numbers becomes very, very important. And actually, we also have prime numbers. You can see how prime numbers are featuring in each and every question, so we really need to know them. Actually, we need to go through the whole schedule of prime numbers from the first 1, 2, all the way up to the maybe the last one just before 100, because they can take you to such ranges like 60, 75, up there, where you need to really go and try out. And in this case, between 60 and 75, we try to eliminate all the even numbers there. We eliminate, especially in the 60s, those that are ending with 3, with 9, with 6. We know those can never be prime numbers. So we remain with 61. So this is the one that some people, they know. 61 is obviously a prime number. But in case you're not sure, try divide it with 7. Because it ends with the 1. 7 times 3 is 21. Try divide it with 19. Try divide with 17. Try divide with all those numbers. So 61 is one of the numbers. And this, the difference between the first question and the second question is, the first question says a multiple of 7. That's one number. But this second question says the prime numbers, which means we have to write all of them. And from 61 we move on. 63 can be 67, yes. If you are doubting, take your calculator, try dividing with those numbers, the 7, the 3, the 19, 17, right? So it's 61, it's 67, right? Then we move on, I think 71 will be the next one. 73 is another one. So you try those numbers, try divide by 17. So those 4 are all prime numbers. So for this session, this concludes my lesson. Thank you.